So today we will discuss about Huygens principle, right? So basically, Huygens was a scientist, which he said that the nature of light is wave. So I'll be discussing that wave theory too. But today let's look into the Huygens principle. Like let's look what he said. Basically, he defined us about wave front. Now, what is wave front? Basically, wavefront is basically a locus. Let me write over here. Basically, wave it is a locus of points of a medium which are vibrating in a same phase. Now, what does that mean? Now, what is basically wave front? So basically, what is wavefront? Basically, wavefront is basically a locus. Locus means a location of a point of in a certain medium which are vibrating in a same phase. Now, what does that mean? What is the meaning of this word phase? Now, basically, we know that according to the wave equation, this y is equal to a sine a sine basically here omega will come. I don't know where's the sign here. Omega t plus k x, right? Basically this is a wave equation, right? So over here, like we know, like according to this hydrogen, light is a wave. So here t for time, right? T for time, right? And here this x is basically the displacement of the wave. X is basically displacement. X is displacement of wave, and this y is basically displacement of particle. Now, what is now basically wavefront? Wavefront is basically a location, or you can say the location of points in a certain medium with they cover equal distance, like the equal displacement in equal time. Basically, wavefront is nothing but these are the points in a medium which are vibrating in same phase, which means they are vibrating with same displacement and same time. So that is known as basically wavefront. For example, over here we have a point source. This is a point source, right? This is point source. Let me write it over here. This is point source from which light is emitting, right? And from here we have certain waves, right? These are waves, basically waves in all the direction in 3D direction, right? So basically this is point source and these all are waves. Let's consider a point over here. Like consider a point A over here. Point A. Now if I say you that find the face of this A. So what will be the face? The face will be, okay, consider the time over here. We have time is equal to T1, right? Time is equal to T1. So if I say that find the phase of this point particle A, so you will say it is basically omega T1 plus kx, right? Because it is covering a certain displacement, which is, for example, over here we have certain displacement which is x, right? Now this was for point A. If I say that find the phase for point B, for point C, for point D, point E, point F, point G, point H, right? So these are basically points on the, these are like basically points of a medium which are vibrating. So if you will look that they all have same phase, for if they have a same phase and they are vibrating with same displacement, same time, it means they are in same wave front, they are in same wave front. So here will form a spherical, will be formed, a spherical is formed. So from point source the wave front is spherical, right? Where point from a point source the wave front is spherical, right? From a point source the wave front is spherical. I hope this is the concept of wave front is clear to you. Like what is wavefront? Wavefront is just the actually wavefronts are the points on a medium, on a medium which basically these points cover equal displacement in equal time. So that's why they are known as same, they are in same wave front. Why? Because they vibrate in same phase. Same phase means they have same time, they cover same displacement. So this was the concept of wave front. So okay, now basically second point which he gave was that the direction of propagation of a ray is perpendicular. Let me write this over here. The direction of propagation of a ray is perpendicular to the wave front. So basically the direction of a ray passing through a wavefront is always perpendicular. For example, um, it's like this. For example, consider, let me erase it. This is a point source basically, and from here we this is wave front. This is one wavefront, and this is another. This is another wave front, right? So over here, as I said, the rays passed over here, they are perpendicular. For example, a ray is passed from here. There is a ray over here. The ray is over here. The ray is here. The ray is here. Over here, right? So as I said, the ray is always perpendicular to the wavefront, right? So this is wavefront because this is perpendicular. This is also perpendicular, right? This is also perpendicular. This is perpendicular. This is also perpendicular. So what the direction of propagation of basically ray is always perpendicular to the wave front, right? So basically there are certain types of wave fronts too. For example, okay, over here we have, okay, if the source is a point source, like from a point source, the wavefront is always spherical, right? So point from point source, okay, we have certain types of wavefront, right? We have types of wavefront. For example, one is from a point source, like from a point source of light, the wavefront is always spherical. It has spherical wave front, right? If for example the point, like the source is from infinity, like the source is from infinity, right? Let me draw right here. It's like this, from the infinity, right? So the basically we know that from infinity the lines are always parallel. The parallel lines are coming. Oh my god. uh Not good at drawing. We consider these are parallel, right? And it is ruled that the direction of propagation of rays always perpendicular to the wavefront. So this is parallel lines because from infinity there are always parallel lines. Parallel lines. So obviously here the wavefront will be formed is in a plane. It is a it is in plane because they must be perpendicular. So basically the source of is from infinity. So the wavefront formed is the wavefront form is plane wave front, right? It is a plane wave front, right? Okay, third which we have is basically when the source is basically linear. The source is linear. The source is linear. Now it's like, hmm, the source is linear, right? It will be, oh my god, I'm not good at drawing. Oh, oh my god, I got stuck. It is like there will be linear lines. We consider they are linear, okay? So for the linear source of light, the wavefronts will be cylindrical. They will be cylindrical. So actually you have to remember some points. So they are cylindrical. So the wavefronts are, they are cylindrical wave fronts, right? The wavefronts are cylindrical. So these were the types of wavefront basically. So we have the fourth point, which is very, very, very important. The point is, like every point every point on a wave front act as a secondary wave disturbance. They act as a secondary wave disturbance which emit oh my god which emit secondary wavelets, right? And secondary wavelets spread in all direction with the velocity of a wave. Now what is actually he is trying to say? Okay, consider that, okay, this is a point source, right? This is a point source and the wavefront is this. This is a wave front, right? So obviously this is point source, this is point source, or you can say the primary source. This primary source of light. It is primary source of light, and as you know, on the wave fronts there are certain points. So these are points. These are also points. This is also point. This is also point. Basically, these are points, right? These are points which I discussed too. These are points on the wave front, right? Basically, these points are now known as source of secondary disturbance. They are known as source of secondary disturbance. They are known as source of secondary disturbance. So the points on the wavefront are known as source of secondary disturbance, and they emit secondary wavelets. So let's say it's like this. They emit secondary wavelets. So these are wavelets. These are secondary wavelets. These are secondary. I know they are not spherical, but consider, right? So basically they emit, this is basically secondary wavelets, right? These are secondary wavelets, right? Now what, let me summarize this. Now this is point source of light, right? And on the wavefront, as we know, there are certain points on a, what is wavefront? Wavefront is basically the location of a points in a medium which vibrate in the same phase, which means that they vibrate with the same displacement same time. So this is a wave front, and on wave front there are certain points. Now these points are known as source of secondary disturbance. So now the source of secondary disturbance emit secondary wavelets, and these secondary wavelets basically spread in all direction with the velocity of wave. What will the velocity e with the velocity of wave? So I hope this is basically most complicated ones. So this is the main criteria, right? I hope this is clear. Now let's move into the another point, which is the last point. Now seventh one. Now what to do, like if you want to create a new wave front? So basically the common tangent on secondary wavelet in forward direction gives new wave front. Now what does that mean? Now basically what will happen, let's consider that like you have to now create, like you have to create draw a new wave front. You have to draw a new wave front. For example, consider time is basically tau. Time is tau. And we know that this wavelet is basically is traveling with the speed of with is traveling with velocity of wave. And now you have to find the basically this distance of this wavelet and how much distance it will cover. So distance covered by wavelet, right? What is the distance which is covered by wavelet, right? It will be basically equal to v. Okay, oh, here is spelling mistake. V multiply by tau because t is time, right? Now by using this you have to, okay, consider that let's make a half wave over here. This consider this is the point source and this is a half wave front, right? And on this wave front we have say a source of secondary disturbance. These are the certain points, right? Now basically by this formula you will get the distance and how much this distance will be covered by a wavelet, and wavelet are produced by secondary dist they are produced by secondary disturbance, right? Source of secondary disturbance, right? So and at that distance, for example, the distance is this distance is this, the distance is this, the distance is this. So on that distance you have to create a arc. On that distance you have to create arc. It will be like this. An arc will be why it's not working? You have to, at that distance you have to create an arc, right? The arc this is an arc. This is an arc, right? This how this arc is created, basically it is a distance which is covered by a wavelet. We know that v is equal to d upon t, so this is just the rearrangement of that this is just a rearrangement of that formula, right? So now you have, as you have created an arc on a distance which came by this formula, now you have to draw a basically a common tangent. Now you have to draw a common tangent which will be joining all these arcs. So this is basically a new wave front. This is new wave front. This is new wavefront. So I hope this is clear that how to create a new wavefront. What you have to do basically, first of all, you have to just get the distance. How you will get distance? Basically, as we know that the secondary, like the wavelets travel with the speed of wave. Now you will get the speed of wave. You have to multiply that with time. the time will be obviously given. When you multiply them, you will get the distance which will be covered by wavelets. When you will get the distance which will be covered by wavelets, let me know where distance, right? This is distance. As you will get the distance, now you have to draw an arc on that distance, and you have to join all the arcs on a common tangent. So when you will draw this tangent, you will get a new wave front. So this is how a new wave front is formed. Let me show you here. I'm also having a diagram basically over here. As you can see over here, how this is formed, how this is formed over here, right? This is a spherical wavelet, and this is wavelet before and wavelet after, right? You can see in this diagram too, this is how by a common tangent this created, right? As you can see over here, this is primary source, these are secondary sources, and this is wavelet, and this is the new wave front. So I hope this is clear to you. If you have any kind of query, you can ask me in the comment section. We're very glad to answer you guys.